Okay, so sorry. Hi again, it's Mr. Carr. Today we're going to be looking at 6 day 2. All right, and this is going to be more with our radical expression. Sorry. We are still going to use our rational exponents as part of that, though. So we want to simplify these. The best way to do this is we are going to start by rewriting into our rational exponents. So this is the same as 16 to the 1/6, and then 2 to the 1/3. Now, this does not actually combine because they have different base values, but 16 can be rewritten into terms of 2. So what I mean by that is this. It's going to look like this. 16 is the same as 2 to the 4th power. So I can rewrite that as 2 to the 4th to the 1/6 power. In my denominator, it's still 2 to the 1/3. Okay? And we make that look a little bit better for a 1/3. I guess I got to write it down here a little more. There we go. Okay. So from there, now we can apply some of our properties. So for example, I raise a power to a power, I multiply those. So that's going to be the same as 2 to the 4/6 over 2 to the 1/3. I'm going to simplify the 4/6. That's going to be 2 to the 2/3 power, and then 2 to the 1/3 power. And now that I'm dividing with the same base, I can do my rule, which is subtract my two exponents. So 2 to the 2/3 minus 1/3. So I get for an answer here is 2 to the 1/3 power. Part of my simplifying, we're going to have it as the cube root of 2. So if the directions say to rewrite it that way, we'll make sure we write it as a radical number instead of a rational exponent. Okay, but that's the bottom line for that one. We want to apply our same exponent properties we've used before, but we want to make sure that a big part of this is that we turn into the same base. So put 16 into terms of 2. Okay, so this one you can try on your own. Same thing as before, turn 4 into base 2. Well, let's look at this one. Okay, so simplify this radical. So again, this one is going to be, we're going to use our exponent rules, turn them into rational exponents. So the first thing to notice is just that when I look at this one, this will be 4 to the 1/6. And I can do them as two separate things because let me show that actually. This is the same as taking the 6th root of 4 times the 6th root of x to the 4th. Okay, so if I do that as my exponent rules, I can do 4 to the 1/6 power times x to the 4/6 power. All right, so x to the 4/6, I can reduce that. That'll be x to the 2/3. 4 to the 1/6, I am not going to have the same exponent here, but I could do this as 2 squared to the 1/6, which means then that's going to be 2 to the 2/6 power times x to the 2/3 power. So that will turn into 2 to the 1/3 now times x to the 2/3. Since I have the same denominator here, if I want to, I could put it back into my radical format. And then these will just both be my exponents, because here's what's going to happen. Be the cube root of 2 to the 1st times the cube root of x squared. Since they're both cube roots, we can put them together as the cube root of 2x squared. Oops. Okay, so that's how we simplify this. This became a cube root of 2x squared. All right, there are shortcuts with this, but I just want to show you step by step what's happening when I try to simplify those. All right. Here's what you can try on your own. Again, don't forget, you're probably going to want to put this in a base 2. Something like that will come up with help on that one. X to the negative 3/5. Okay, so when we do this one, just like we've actually done one like this before, we start off by flipping into the reciprocal, make it 1 over x to the 3/5, which means that is 1 over the 5th root of x to the 3rd power. We don't like having radicals in our denominator, so I'm going to multiply this by the 5th root of x squared. That will give me x to the 5th on the inside. So I do that to the same thing to my numerator. And that's going to be the 5th root of x squared over the 5th root of x to the 5th, which this will cancel out. So it turns into the 5th root of x squared over x. Okay, so now with this one, we can rewrite this out. Actually, no, I think we're going to want to leave it that way. So yeah, we're going to want to leave it like that in those terms there, because if I were to try to subtract them back, it would go back to the negative 3/5 again. Okay, so we'll leave it like that. You could do it as x to the 2/5 over x. But yeah, that doesn't do much of a difference there. So I just know that those are, I guess, the same at that point. All right. So this one will be a bit of a challenge. So we want to simplify this one. And we're trying to get, the goal is to get our rational exponent out of the denominator. In order to do that, we're going to do kind of like we've done before with conjugate pairs. If we multiply this by x to the 1/2 minus 1, okay, we should help get rid of something on here. Okay, give me 1 second here. Okay, sorry about that. So when we do this, we're going to go ahead and do our distribution rules. So my numerator, I've got x times x to the 1/2, which will be, I'm adding the 1/2 plus 1/2 is going to give me x to the first. And then negative 1 times x to the 1/2 power. Here's another -1 x to the 1/2 power. And then -1 times -1 is a positive 1. In my denominator, I'm going to have x times that is going to give me x to the first. And then negative x to the 1/2, positive x to the 1/2, and then a -1. Okay. So again, in my conjugate pair idea, these will cancel out in the middle, so I don't have any more rational exponents is the goal. In my denominator, I can start combining things together. So I have x to the first minus 2x to the 1/2 plus 1. And then in my denominator, I have x minus 1. And that's actually as simple as we can get with this one. We're not going to do anything else here. We cannot, we don't feel it. It's not necessary to try to get rid of this. We just want it out of the denominator. Okay, as long as this is just a kind of a polynomial, we don't have to worry about that. So that's one you could try on your own, which is the same thing. Yeah, that's the same thing. All right. Okay, and that's it for today. So I do want to leave it on this one because this is a good summary of how do we simplify here. So an expression with rational exponents is simplified when all the following conditions are met. We do not want any negative exponents. Okay, has no exponents that are not positive integers in the denominator. Okay, it's the positive integers part. So for example, if I have 1 over x to the 1/2, that's not what we want. We want it to be, like in this case, this would become, I think, like x to the, like, I don't know off the top of my head actually, but we want this to be, basically we got to get rid of all fractions in my denominator. Okay, so that's how we can summarize that. No fractions in the denominator. Okay. Yeah. All right. It is not a complex fraction, so we're not dealing with any i's in there. Okay, and the index of any remaining radical is the least number possible. So you notice how before, if I have the 6th root of something, I was able to turn it into the 3rd root of something. Okay, so that's the goal there. Can we get it down to a simpler value? All right, and that's it for 6.6 day 2. So keep working on those rational exponents and take care.